Hi there, this is Abhishek, and in this video I will continue my conversation about the time series forecasting. So far you have seen the fourth part where we started the time series with what is time series and why to use it, and in the last video I have talked about time series forecasting for trend and seasonal component, and there I gave you the a discussion point for this video that we will going to do some testing. So here in this video I want to show you some of the methods that you can use for testing the time series forecasting and see whether it is giving you the right result or not. Alright, so we will going to use the same code for doing the time series testing, and from here onwards we actually started predicting the forecast. If you remember from previous video, we predicted or we forecasted the rains that were going to happen in India based on the yearly rain data we got it from the government website. So the first test is the ACF. The name of the function is ACF, and what it basically tells is autocorrelation function. So the basic idea behind the ACF function is that it will going to plot some values for us, and what those values are, so they are basically the forecast errors that have been plotted on the next predictive values. So if a model is good, then your forecast error should not be related to the successive values or the predicted values. If there is a correlation between the forecast errors and the predictive values, then definitely that model has the scope for improvement that can be improved by applying either another methodology or transformation or anything based on the given methodologies within the time series forecasting. So what we are doing over here is we are using the ACF function, as you can see, and within that we are plotting the residuals. So this particular object that we earlier created over here, and then its component which is residual. So what residual is, in theory, it is basically the forecast errors or forecast errors based on your sample data that you have used. So it's a difference between the actual and predictive values, and whatever is the difference is basically an error. That means we have not predicted well. If the error is large, that means there is an issue. If the error is small, that means we have a good forecasting. But the idea here is that we want to plot these forecast error for these next 10 predicted values, as we have predicted the next 10 values, time period values over here. So let's go ahead and try to execute this. And one other important change I just did, I realized that I have not used the na.exclude. So if there is any na value, it will not run properly. So that's the method you should have, so that we are removing any na values from the residuals. So press Ctrl Enter. Alright, so here we have the ACF. So what it is basically showing that this is the lag 1, 2, 3, 4, 5, and this is the minimum and maximum boundary, and no lags are basically touching it. So here I think on the lag 17 or 18 it is going near to the boundary, but it is not crossing any boundary. So that means there is no significant correlation or correlation is present between the values, forecast errors, and the predicted values. So that's one way of doing it. Another way is using the Elgin Box Test, which also check for the correlation. So if we go down here and execute the command by pressing Ctrl Enter, and here the p-value is 0.4. So that basically indicates that some little bit level of correlation is present, but it is not very significant. And then we have the option of plotting the forecast errors. So there should be the constant variance on the forecast errors, with the mean should be near to 0. So let's try to plot it and see it in action. So here, if I can zoom it for you a little bit. So as you can see, if you are not able to identify any significant patterns, so this one is basically going up in the start and then it's going down, and in the middle it's pretty normal. Here also it's pretty normal. So there is no significant trend like first it is starting with low variance and then high variance, or initially high variance then the low variance, or it is showing any kind of trend or anything which you can think of as a pattern. Then it is a problem. But if it is a random variance like this with a mean near to 0, this particular one, so if you see mean is nearby to 0 only, so that you can say that, then you can say that your forecasting that you are doing is good based on these forecast errors. Finally, what you can do is you can plot the forecast error to test the normality of data values using the hist command. So if I press Ctrl Enter and use the zoom, so that's the forecast errors which is near to the 0. And as you can see, it's pretty normally distributed. I don't think it is even right skewed or left skewed. This is pretty normally distributed with a mean, with the values aggregating near to the 0. That means we are good to go ahead with this forecast series. Well, these are some of the I would say a little bit basic to intermediate level testing that you can do. Apart from that, I have seen that people use different level of testing based on their specific data type and the type of the data that they are using, as well as per their business conditions. Even sometimes you can even drive your own formula to test it. So that you can do only when you are experienced enough into this testing and understand some of the components about where it can go wrong, and then you are testing that part. So if you have followed my previous videos, you must have seen that I have used yearly sales forecast, future, and the passenger model, and the same script I have used over here to test the model. What I would really like that you go ahead and try to implement this in your model, because, or in your script, and then try to interpret it, what output it is giving. And I would really like to see your outcomes, or the information that you are getting for the ACF function, for autocorrelation, the box.test, plot.ts, histogram. So all of these errors that you are identifying based on the values that you are getting. But this process doesn't end here. We will going to discuss in upcoming videos about the ARMA and ARIMA methodology for doing the time series forecasting, which is a very well known and quite mature and pretty automatic way of doing it. We will cover it a little bit in theory first of all, and then go ahead with the experiments and then the testing and everything. And what I would really like is if you can share your experiences about the key videos that I have covered over until here, that what kind of significant things that you would really like to see, or you want me to work on. I would try my best to cover up that particular topic or feature in the video, and try to see where we can get the more output from these videos. And like always, you can find the all that script into the link that I will give. So what I usually do is post this entire script on the related blog, where I have the option of pasting the script, because YouTube does not allow the pasting of script within their description. So link is mentioned in the description. So if you want to get this entire script, then follow the description, and there you will find the link from where you can copy and paste the code. So that's all I have for you in this video, and I will meet you in the new video with a new topic.